so that data will be able to drive the cars and all that thing. Because if we use object detection in that case, then we are not able to get the correct location of that object and all that thing. That might be the case that the car will hit that object, so due to lack of the data, like where the object is. So we'll use object segmentation and all that thing to measure the distance and the specific location of that image. So that is image segmentation. We have seen this whole like image processing, how the image processing work, like how we can read, manipulate image, how we can write that thing and all that thing. We have seen this thing. Anyone has any doubt in this? Anyone? So like I just want to confirm one thing, like wait for a minute. So like I just wanted to ask, like anyone is having any like issue or any problem with this mentorship program or anything like that, you can share it with me. Then I'm going to inform the management, and your issue will be resolved based on your. Yeah. So anyone has any issue with this mentorship program or anything like that? Anyone? I think the timing will be not the issue. Like everyone will be comfortable with this timing, 6 to 7. Does anyone have any issue? If you have like examination and all that thing, you will take you will drop a mail to me. I will review that thing, and that will not be any issue for you. So yeah, that is not the main thing. But if you have any specific issue and other thing, then you can like if you want, you can drop me a mail, or you can share it over here, so we can discuss and we can resolve that thing. And one thing I want to mention is the rule is something like that. You have, like if you are having examination and all that thing, you can take a leave, but the minimum criteria is you have to attend a minimum of 3 lectures a week, right? You have to attend 3 lectures minimum. And one criteria is already there, that is in case if you want a certification and all that thing done, then you have to be present in 75% of the classes. So that is the main specific area, like the main rules to get this certification and this project done. Okay, anyone has any doubt? No one? Okay. So yeah, so see, this is the main work of the computer vision. So like why we are using computer vision and all that thing. So this is the main thing that for this use case we are using the computer vision for our use cases. So one thing is acquiring the image. So the thing will start with the data collection. We, in case if you want to like start with computer vision and all the thing, we need data. So acquiring an image is the first step to start with the computer vision and all that. So image like we have number of images and all that thing in the computer vision library to get start with the computer vision model and all that thing. Second is processing of the image. For this purpose, we are using deep learning models and libraries like TensorFlow, PyTorch. For the development of the computer vision model, we use PyTorch and TensorFlow. Wait for a minute. So yeah. the processing part will be handled by one is OpenCV that we use to like process this in processing of the video, and another libraries are like PySA, TensorFlow, PyTorch, Keras, and all that libraries are there to build the models from scratch. If you like, we are using YOLO model, right, for this purpose. But if there are some cases where you need to build the model from scratch, so these libraries will be helpful to build the model from scratch. So library providing many like functions and methods that will be helpful in case if you want to build the model from scratch. Wait for a minute, I have some work. Wait for Yeah, so the next part is understanding of the image, the final step that we have to see. So understanding of the image is based on your model configuration, all that thing. So the image will be understood by these models for computer vision like YOLO and all that thing that you will build. If you build a custom model, then the understanding of that image will be based on your model depth and the model parameter and all that thing, like how much data you trained your model on. So that is the basic criteria. And if you are trained your model with like a small amount of data, then model not going to give you that much accurate results to you. And if you train the model on like large data set and uh, like good quality of images and all that thing, then your model will be like able to give you like good results and all that thing. So that's the thing that we have to consider. Wait for a minute, I have some tasks to complete. I will get back to you in 2 3 minutes. Yeah, sorry for the interruption. So see, this is how the computer is like seeing the images and all that thing. So like we are having this image, and this is the annotation that has been done. Like computer is seeing the images in this form. The matrix of multiple numbers, two directional, or if we have colored image, then the matrix will be of 3D. And this is how the computer is like going to interpret the images and all that thing. Wait for a minute. Yeah. So in computer vision, there is mainly three functions, like three main areas that we have to learn. So these are these three things. One is convolutional, second is pooling, and the third one is non-linear activation. So have you guys heard about the CNN, like convolutional neural network? That is the like building block of this computer vision. So the convolution, like what is the convolution? Wait for a minute. Yeah, see. So the image will be represented in this format, the two-dimensional array of the numbers, and the convolutional is nothing but 3 by 3 or 2 by 2 matrix that will be going to roll down these images, and it is going to extract the numbers from that square, and going to plot that number into this thing. So like yeah, we are having minus 101, 212, and 1 minus 2 0 in the convolutional 3 by 3 matrix. So what we are going to do is we are going to multiply all these values with these values, and going to sum up all that values, and after doing this we will get one value that will be going to process in next layer that we are going to see in the upcoming lectures, like you can see over here. Yeah, see. So to like image will be passed in this format. The see, there is one convolutional that is 5 cross 5 matrix that is going to roll on this image and going to collect the values that here we got 5. So this convolutional is going to pass all on the images and going to collect that value. That value has been taken in these different formats, and then what we are going to do is we are going to use the pooling. So pooling is nothing but if the convolutional network is going in this dimensional, right? In so if there are two concepts in pooling, the one is max pooling and another is mean pooling. So in case of max pooling, what is going to do is it is going to take the maximum value that is there in that matrix. So in this case the maximum value is 9. So in case of 5, it is going to take the 9 in case of max pooling. But if it is mean pooling, then it is going to take 2. So in case of 5, there will be 2 in mean pooling. So that is max pooling and mean pooling. And this thing will go in convolutional network in forward layers and all that thing. So that will be passed through this different convolutional network. So there is one 5 cross 5 convolutional network. Then we are having mean pooling. Then again the 5 cross 5 convolutional neural network. Then again mean pooling, and then the fully collected neural network, that is artificial neural network. We pass these collected features into artificial neural network, and artificial neural network will provide us the result for that thing. So see how the object detection is going to work. So first we have an image as an input, and then what happen is, yes, yes, Vaibhav. Yes, Vaibhav, you can unmute yourself. Am I not audible?
Yeah, sir, you are audible.
Okay. So like Vaibhav has read your his hand. Like, do you want to say anything, Vaibhav? Okay. So yeah, see. So the thing is something like CNN is going to give us the location of the objects. So CNN is detected that there is some objects in this region. So it is going to provide us the location. Then if we want to know that what is the object over there, so what we are going to do is we are going to use the CNN architecture to detect the, like, is there is a person or aeroplane or car or anything. Then what we do is we take the values of this region that is there, we have seen here. This is the value. We are going to take the values of that region and then going to pass it to the convolutional neural network, and the convolutional neural network is going to tell us that yes, there is a person or there is a aeroplane, there is a cat, dog, or anything that is there. So convolutional neural is going to give us the value of that object. Yeah. So anyone has any doubt? Anyone? No one? You got the point? What I'm trying to like explain?
Yes, sir.
Yeah.
Sir,
Yes.
what does it mean by pulling?
Yeah. What?
Pulling, sir, pulling.
Pooling. Yeah. So
Yes, sir.
see what the pooling is. Pooling is nothing. We are getting like this is the matrix. That is the convolutional kernel. So what it does is we multiply. This value might be different. In case of different images, this values might different. So what we are doing is we are multiplying these values with the kernel size values, and we are summing, like we are doing addition of that all values, and we are getting some values as the output. So in pooling, what we are doing is there is mainly two concepts in pooling. One is max pooling, and second one is mean pooling. So in case of mean pooling, what we are doing is we are taking minimum values of that kernel. So here the minimum value is 2. So what we are going to do is we take 2 as the output directly without any computation. So this will help us to reduce the size of the data. Like we are having 9 cross 9 matrix over here.
So,
Yes.
so mean pooling is the average pooling, not
No, no,
MEAN.
there is a three, not MEAN. I mean to say MIN, minimum, not the mean, that is average. Mean pooling and max pooling. There is one concept that you are talking is that is average pooling. Got it?
Yes, sir.
Yeah, I don't talking about, like, I am not talking about MEAN, but that is minimum pooling. That is I'm talking about. So you have to take the minimum number. So without any computational processing, you take that number directly, and this will help us to reduce the size of that images and the data. So how it is going to reduce the data? See, you can see here we are having 9 cross 9 matrix over here. So after doing mean pooling or max pooling, what we are getting is we are getting only one value. So that is how it is going to reduce the size of data and help us with to saving the computational resources and time. And the max pooling is as it is, you can like you take the highest amount of that matrix. Got it, Anirudh?
Yes, yes, sir.
Okay. So yeah, that is it for convolutional. So I'm in with one website over here. I will share the link of this website with you. Or you can see in this website we are having some visualizations. Like I can go in object detection, so you can get to know that how the object detection work, how you can do the object detection and all that thing. You can see over here. So that is how like it is detected the objects over here. So then again going ahead. So see if there is some cases, then the computer vision is going to detect one object two times, right? So in this case what we can do is we are having one concept of intersection over union. So what we are going to do is we are going to take union of these two detection, and if the union is greater than 50%, then we are going to consider only one object over here. So you can see here that the union of these two objects is yeah, pretty much greater than 50%. So that is going to be used as a one object only in this case as well. You can see the union of these two objects are greater than 50%. One thing is this, and another thing that I wanted to tell you is this. See, I told you about this kernel and all that thing. So this is how the kernel is going to work. Kernel is going to pass in all the section of the image, and then it is going to detect the objects and going to return us that objects. So you can go through this website. It is having all these different use cases and all that thing. This is the concept of intersection over union. So you take the intersection of the both the detection, and if it is greater than this like you would say 50%, then it is going to take that as a single object instead of two objects. This is segmentation. You can go through this. There is multiple things like how you can do object tracking and all that thing, and that is going to be there. You can check out. Let me take your attendance first. Today is 11 of November. Priyanshu Ching Chauhan.
Present, sir.
Okay. I am Ashwarma.
Present, sir.
Kudi Sai Mehta.
Present, sir.
Okay. Subbalakshmi.
Present, sir.
Chanani.
Present, sir.
Somyajit.
Present, sir.
R. G. Sharma.
Present, sir.
Vaibhav Bari.
Present, sir.
Shraddha Sagar Patil.
Present, sir.
Nagarjuna.
Present, sir.
Anchal Chal.
Present, sir.
Pratha Saradi.
Present, sir.
Rudra Pratap Singh. Rudra Pratap Singh. Gurunath Uday.
Present, sir.
Anirudh. Atharva.
Present, sir.
Prasad Sharma. Prasad Sharma. Rohit Chaudhary. Pitali Thakur. Sarita Thakur, the Mittal, Adia Falke,
Present, sir.
Balam Sainithya, Bhumika Samal, Bhumika Samal, Arman Sharma, Arman Sharma. Is Kavita Thakur is there? Okay. Yeah. So there are some tasks that is the some use cases of computer vision like classification, detection, segmentation. One is object detection that we detect the objects that is there in the image. Second is image segmentation that we have seen that we segment the images into different objects. There are multiple types and techniques of image segmentation that you can see over here. And the another thing is face detection. We detect the face of that person and all that thing. That is covered in the face detection part. Then one part is edge detection. So like if we are having one object and we don't want we have to detect the edges of that object. So that thing will be covered in this thing. Like if you are a cricket ground and you want to detect the boundary of the cricket ground, then this edge detection will be helpful in that case. And yeah, this is the one use case that we can use image restoration. Like if you are having a dull image and if you want to restore that image, then you can also use computer vision to restore that image as well. There are some techniques from which you get this thing done by computer vision. One thing is feature matching. So the feature matching is what see here. If you are having a building and you want to detect the corners of that building, so you are using the feature matching to detect that feature. So corner is nothing but in computer vision or you can say machine learning language, these corners are features for a machine. So if you want to detect that feature, then this thing will covered in feature engineering, like feature detection. This is one scene restoration. If you want to restore any scene and all that thing, and that thing is not useful for us. You can see this one video motion analysis. If you want to analyze any video or like any movement and all that thing will be covered in this video motion analysis. Yeah, you can go with these things. Like there is multiple technologies you can use for like self-driving cars. I said this thing will be useful in self-driving cars, augmented reality, AR, VR. If we can use computer vision in AR, VR as well. Medical imaging, if you want to detect lung cancer, anything that thing, you can use computer vision in that case. It can be also used in the case of MRI detection and mind detection as well. You can see this thing. Yeah, intelligent video analysis. So you can use computer vision for video analysis purposes and all that thing. It can be also used in manufacturing and construction industries. Like if you want to detect that vehicle, like the person wear a helmet or not in the site of there is a construction site, and if you want to detect that the safety will be not compromised, then you can implement this computer vision solution to detect like if there was like that person is wearing the helmet or not. So that thing will be done using this. There is also a use case like OCR that we are going to see in the upcoming lectures. So if you want to extract any text or values from given image, then you can use OCR as well. So yeah, this is it for this lecture. You can go through this documentation. This will be very helpful to you to get the idea of this different computer vision use cases and challenges and all that thing. And yeah, hope you guys enjoyed this lecture. See you tomorrow. Thank you for attending this lecture. Yeah, bye. Bye everyone.
Thank you.
Bye,
Thank
bro.
you, sir.
Yeah.